Welcome back to the series JavaScript functions, and this is the last topic of this playlist. And in this and subsequent videos, we will explore the concepts of callbacks, promises, and async await. Well, understanding these concepts is critical to write efficient and scalable code. We will start with callback, and in this video, we will learn about the concepts of the callback, understand the difference between a synchronous and an asynchronous callback. We'll learn to write a synchronous callback function. We'll understand the benefits and the challenges of callback. We'll understand a very important concept of callback hell and learn about the JavaScript execution context. Watch this video to master synchronous and asynchronous callbacks. Learn how to identify and avoid a callback hell once and for all. We start with understanding the concept of callback. In JavaScript, functions are first-class citizens. If you're not aware of this concept of first-class citizens, I suggest you to watch the two videos, Functions as First-Class Citizen, which are part of this playlist. The link of these two videos is mentioned in the description. If you are new to the JavaScript functions, I suggest you to review this whole playlist, and I have given the link of this playlist in the description below. Now, coming back, in JavaScript, the functions are first-class citizens. This means that we can pass a function as an argument to another function. And the function that accepts another function as an argument is called a higher order function. We generally call this an outer function to facilitate an easy understanding of the concept. The function that we pass as an argument is called a callback function. We also call this as an inner function, again to facilitate easy understanding. Let's understand this with the help of a synchronous callback example. I start by writing a function filter numbers. This function receives two arguments, an array of numbers and a callback function to filter the numbers. Based on the filter criteria defined in the callback function, the function filter numbers filters the numbers from the array and returns a new array of the numbers. Now we will write a callback function. The first callback function is named isEven. It checks whether a number is even or not, and for this I divide the number by 2 using the modulo operator, which returns the remainder. If it is 0, the given number is even. Now I define an array of numbers and call the function filter numbers and pass this array of numbers and the callback function as an argument. Here the function filter numbers is a higher order function as it receives another function as an argument, and the function isEven is a callback function. When I execute the function filter numbers, it returns an array of even numbers. Now I want this filter numbers function to return an array of odd numbers. And for this, I write another callback function isOdd. And this function, just like the earlier function, divides a number by 2 using the modulo operator that returns a remainder. And if it is not 0, then the given number is an odd number. To get an array of odd numbers, I just have to call the function filter numbers and pass on the new callback function, which returns an array of odd numbers. The code snippet we have seen just now is an example of a synchronous callback. A synchronous callback is a function that is passed to another function and executes within the execution context of the main function. So when a callback function executes, it blocks the main function's execution, and the main function waits for the callback's execution to complete. In the example, you must have noticed how easy it was to customize the behavior of the function filter numbers. I can easily customize this function to filter prime numbers or numbers that are multiple of 3 and 5. The callback functions also help in achieving modularity as it enables us to write small and reusable functions. Now we are going to talk about asynchronous execution. And in this programming model, the main program initiates the tasks and continue with the execution of subsequent tasks without waiting for the earlier task to finish the execution. Now this concept is very important in JavaScript. Since JavaScript runs in a single threaded environment, only one operation can occur at a time. Asynchronous execution allows JavaScript to handle time-consuming activities like reading and writing from files, some network operations, etc. without blocking the other tasks. Let's get a better understanding by writing some more code. Now I write 3 functions with a console.log statement. The second function runs a for loop to simulate some time-consuming task. When I execute these functions in synchronous mode, the function third task waits and starts only when the second task finishes. Now I'll make the function second task asynchronous. This means that the moment I execute this function, JavaScript will immediately start executing the function third task without waiting for the second task to finish. I have used the function setTimeout to execute the function second task. The function setTimeout accepts two parameters. The first is the function name we wish to run in asynchronous mode. I have mentioned the function second task here. And the second parameter is to add a delay in the execution. I have set this to 0. So when the function setTimeout executes, it puts the function second task in the callback queue with the desired delay for execution. The program's execution continues with the third function without waiting for the second function to complete. By the way, we will learn more about this callback queue in few minutes. Now we will discuss about asynchronous callback. It is a function passed to a main function as an argument. Now the main function executes a task asynchronously and calls the callback function when the asynchronous operation is complete. These callbacks are generally called to handle the result of an asynchronous operation. Let's understand this with the help of an example. I start by writing a function called fetchData with one console.log statement to simulate data fetching from a DB. The for loop simulates a delay in fetching this data. The second function, processData, simulates the functionality of processing the data we have fetched in the earlier function. This function executes when the fetch activity is complete, and this is my callback function. The third function, doOtherWork, does an activity which is independent of fetching and processing the data. Now I write a main function processTasks, and this function executes the fetchData function in asynchronous mode using the setTimeout function. The first argument of the setTimeout function is an arrow function that sequences the task of fetching the data and then processing it, independent of the main function execution context. When the function processTasks executes, it starts by fetching the data and immediately proceeds to other tasks without waiting for it to be fetched. When the data is fetched, the processData function processes it. We have seen an example of a callback. However, when we have multiple nested callbacks, it creates a complex pyramid-shaped structure. This is the concept of callback hell. The nesting makes the code logic hard to read and understand. The maintainability of such code is not easy, and in case of error handling, there is a lot of repetitive code. The code snippet you're looking at gives you a glimpse of a callback hell. In this code snippet, I'm reading three files. The function read file is an asynchronous function. The read activity happens in a sequence, and after every read, I combine the data. Finally, I write the combined data in a new file, and the function I use is a write file, which is also an asynchronous function. Note the repeat code for error handling in this code snippet. Now imagine if I have to add a new file for reading at the second position, how hard it will be to make this change. To address this, JavaScript provides a feature called promises, which we will look in the next video. Now we'll come to the last part of this video where we'll understand the JavaScript execution context. JavaScript execution context is a component that sets up the environment in which the code executes. It manages the state of a program during the execution, and which includes variable scopes and accessibility, tracking call stack, managing asynchronous operations, error handling, memory management, etc. Now we will understand this execution context with respect to managing call stack and asynchronous operations. We know that JavaScript is a single-threaded application, yet it gives us an impression of parallel execution by executing the code asynchronously. One way to make code run asynchronously in JavaScript is to execute a function or a code block using the setTimeout function, and we have already seen this example. Other ways to execute code asynchronously are promises, async-await, setInterval, and event listeners. In the subsequent videos, we will learn about promises and async-await. Coming back to the call stack, it is an important part of a JavaScript execution context. It tracks which functions are in execution and which are called but not yet completed. It works as a stack data structure in a last in first out manner, which means the last function added to the call stack will be the first to execute. Now, whenever a function is called, JavaScript creates a new function context and pushes it to the stack for execution. It pops out when the function execution finishes. Now, since JavaScript is a single-threaded application, it can execute one piece of code at a time, and the call stack ensures that the functions execute in a sequence without overlapping. In this animation, you will see each function calls another function in a sequence until the output is displayed on the console. With each call, the stack keeps filling up, and once the information is displayed, each function starts popping out of the stack in the reverse order. Now, coming to the callback queue, just like a call stack, a callback queue is an equally important part of the JavaScript execution context. It is also known as a task queue or message queue, and it works along with the event loop to manage asynchronous code execution. It is a first in, first out queue. When JavaScript executes an asynchronous code operation using setTimeout function, it puts the callback function in the callback queue and waits for the synchronous code execution to complete. It means it waits for the call stack to be empty, and once the call stack is empty, JavaScript pushes a callback function from the callback queue to the call stack for execution. Now, coming to the event loop, JavaScript uses the event loop mechanism to manage the execution of asynchronous operations in a non-blocking way. It manages the interactions between the call stack and the callback queue. The event loop constantly checks whether the call stack is empty. When empty, it checks the callback queue and pushes the first available task to the call stack for execution. This process repeats until all the functions in the callback queue are complete. Just to remind you again, this is a very simplified explanation of a JavaScript execution context which includes the callback queue. There is more to the Java execution context which this video is not covering. Now, this sets the foundation we need to understand and appreciate the concept of promise, making the code easy to understand and maintain, which we will learn in the next video. Let's summarize what we have learned in this video. Thank you for watching this video. If this video has helped you, please like it. If you think this can help any of your friends, do share it. And finally, do subscribe so that you don't miss any other videos in future. Thank you very much. Keep learning.